Welcome to this presentation on the core of our applications, the Empolis Intelligent Views Platform. My name is Alexander Firyn and I have the pleasure of being the product manager for our platform. So this morning I presented Knowledge Express to you together with my colleague Eddie Mönch. And we also saw this example there, the linked information about a cosmetic product. So we learned it contains Arachis hypogaea oil, which is a form of Arachis hypogaea. Arachis hypogaea is the official name for peanut. So the industry has to use this name for the declarations on the cosmetic products. And in German, this is Erdnüsse, in English peanuts, and the Swiss say, as we learned, Spanische Nüssli. And in the so-called CAS system, it has the chemical product number 2228777. So these are all different representations for the same thing. And we see even more information about peanut oil. Peanut oil contains many unsaturated fatty acids. So we can save this information, can link it to the peanut oil. And it therefore nourishes the skin, which is good. But many people are allergic to peanut oil. That's not so good, and we need to know if we have peanuts or some products based on peanuts in our products. And finally, we can see if we want to buy peanut oil, we can get it under CAS number 2228777, for example, from Livchem Logistics for 662 euros per package. Okay, that is what is saved in our knowledge graph. The fact that we can collect and use this data in context is thanks to three features that are included in all of our products. First, the ability to easily integrate data and systems. Second, the knowledge graph itself to link context and relationships. And third, our semantic search capabilities, which are on the foundation of all our products. Within the Empolis Intelligent Views Platform, we combine these capabilities to provide you with an easy way to capture all information and sources in knowledge-intensive processes across the entire life cycle, link them together, and share them with others in trustworthy manner. Easy to use and optimally integrated into your office products and browser environments used on a daily basis. So this makes secure decision-making fun again. Our generic approach to build applications on our platform is straightforward. So step one, bring all your existing data together in one spot and find what you are looking for faster. Second step, save all your findings in knowledge graphs, ensuring that your discoveries and findings are never lost again and that they are interconnected. The third step, make better use of your collected knowledge whenever you need it, instead of starting all over again and again. So act, analyze, and aggregate. The Empolis Intelligent Views Platform enables us to implement our standard applications for you. So first, the Knowledge Express for decision support, Content Express for product information, and Service Express for better service knowledge management. But not only our three standard products are based on our platform, but countless other applications. I would like to present two of these applications to you today as examples, and all of them are simple, seamless, and secure. The first example is a very simple assistant that can help you with shopping or with selling, depending on which side you are on. I brought this small example because it's a good example of a solution that can be implemented in just a few days and provides tremendous value. The second example describes the other end of what can be implemented with our platform. I would like to use a very simplified example to show you how we bring together information about people in large registers. Such solutions often became very large and they are the basis for many database decisions. So I brought this example to show you that there are no unmanageable black box processes at work in such registers. Instead, we can design even large data collections in such a way that every recommendation made by the software is traceable and verifiable. And in the end, human experts make important decisions on top of these recommendations. The first example now I want to show you is a fairly simple application implemented on our knowledge graph. It's a wizard for choosing the right dog food. When you have a look on it, you can see the wizard asks a series of questions. The goal is to determine all the correct information to be able to suggest the best food for your dog. But along the way, the assistant also points out things that the user should know because they don't meet the expectation. So now such thing comes here. Yes, for example, our dog here is a bit fat. Maybe the owner wasn't aware of that yet. And in the end, we receive a justified proposal for the best product. Should come soon. So now we answered all questions. And we get an explained recommendation what kind of food we should buy for our dog as the best product. The charm of the solution in the system, the characteristics of the available products and the typical characteristics of the known dog breeds need to be recorded only once. The questions and recommendations then result from a set of rules that relates these properties to each other. So you have a very simplified data management. Therefore, such a system can very easily be extended to include new products or new dog breeds or, if you think it further, new kinds of food for other animals. That's pretty simple, isn't it? And you can see how useful something like this actually is when you look at the typical searches of large online stores. Let's have a look on an example. So try searching for dog food on Amazon. Amazon is great, but you will get a lot of selection criteria, and this will not help you. Because, like most store systems, this catalog contains a lot of information about the available products, but does not make a match with your current needs because he does not know what need you have. Another pity. If you search for a 2 terabyte hard drive in Kaiserslautern at the big electronics providers, you won't find anything. Why? Because the system does not understand that Kaiserslautern should not be in the hard drive, but the hard drive should be in Kaiserslautern. It still does not understand what you mean with Kaiserslautern. I could show hundreds of such examples, but you experience them yourself every day. So let me just say, this can be done much better without making the solutions more complex. Allow me to make a small appeal at this point. In recent years, the impression has spread that self-learning AI systems can answer all our questions. We just have to feed them with enough data. But the problem is that there is not enough data for every question. Deep learning is super effective at repeating the past, but quite overwhelmed with new or rare problems. But that doesn't mean AI can't help us. We just need to go back to using all the methods AI offers us. There's more than deep learning and neural networks and such things. Take a look at the current Gartner hype cycle. Semantic search also overcome the value of tiers on a broad scale. And knowledge graphs have reached the summit, but unlike many other summiters, it's a proven technology. And if you don't trust the analysts, check out the results of the latest NetHack challenge. So NetHack is one of these classic Unix games that, with its many surprises and tricky decisions, is probably closer to life than Go or chess. So it's no surprise that symbolic AI systems are much more powerful at playing this difficult game. You see the 3 red bars on the right at the bottom? The top scorers in this challenge used symbolic, rule-based AI approaches to play this game, and they won. Only in 4th place and far behind could the best deep learning system score. That does not mean that one approach is better than the other, but both have different strengths and weaknesses, so each technology for its purpose. It is in combination that we find the greatest benefit. Let me come to the second example. Here we use a whole battery of AI processes. Some of them are data-driven, others are based on rules. All procedures are part of our Intelligent Views platform. So imagine a data registry, for example, from a government agency. So I built a very small register. It has only 4 records, and it's very, very small. But you typically want to merge all data that relate to the same person. But the data comes from many different sources, and they don't all use the same ID. So within a register, you want discrete attributes with discrete information, for example, the first name, the birth name, and so on. But on the documents, it's not clear what kind of string there describes the first name and the other attributes. Potentially relevant information is stored as individual values to map information from different data types to one consistent data collection. So this builds up the register. This information is recognized either via the structure of the incoming document or by means of AI algorithms from the full text, from the unstructured text, where we have to recognize what kind of information matches to which attribute. In practice, such registers can contain several billion data records. So if one or the other of the procedures now presented seems very simple to you, I will say 2 things about it. First, yes, AI approaches are usually very simple if you look at them in isolation. And second, even simple procedures that can be executed reliably and quite challenging if the amount of data is large enough to make the use of software necessary. So how does a register like this grow in practice? This is one of the things we have to do. Whenever a new document arrives, a new record is first created. This is simple. Various linguistic procedures are already applied. For example, the assignment of the name components to the intended attributes. So here you can see the linking of the first name and the given name, the first name and the last name to the right attributes. And you see they change order. So then after that, a variety of semantic procedures is used to check which existing entries the new record is similar to and whether it can be linked to another. So we would not simply have a new entry, but another piece of information about an already known person, so that we get more knowledge about a person or another kind of information. Some of these possibilities are presented below as examples. First step. When analyzing the document, the included base linguistics automatically recognizes that the name is listed in Arabic letters. That is not practicable for our register because our register uses Latin alphabet and Arabic letters does not match with Latin letters. So we adopt the automatically generated transcription from the Arabic alphabet to the Latin alphabet. And then we obtain Erika Mustariman in Latin spelling as a result of this transcription process. And initially, it's a proximity to existing record number 4, which is also about Erika Mustariman. So, one similarity. But transcriptions are not always unique. Therefore, we determine, in the next step, the phonetic code, which, according to an existing set of rules, only represents how a word would sound if we were to pronounce it, ignoring the vocals, regardless of the actual spelling. So the phonetic code of Erika Mustariman is 074682766. And this is identical to the phonetic code of Erika Mustermann, a name we know from lot of example documents in German. Thus, the data set is initially equally similar to all existing entries. Next step. Let's do a kind of semantic analysis. Let's work rule-based and model-based. The Arabic spelling could be an indication of origin from an Arabic country. Since the Erika Mustermann from dataset 3 has her birthplace in Syria, in Damascus, and we determine from a semantic model that Syria belongs to the Arabic language area, we initially weight this entry somewhat higher. So we have a new kind of similarity which could bring us to the decision that this is the right match. But we can evaluate other clues for possible proximity to existing entries. For example, the airline ticket names SVO as the place of departure, which means Moscow, Russia, as we know from another semantic model. In our existing dataset too, we already have an Erika Mustermann of Russian origin. This can also be a weak indication of a connection. So the new dataset does have features in common with 4 of the existing entries, with all 4 existing entries. However, in some, all the clues are too weak to perform an automatic linkage. This is where expert knowledge comes into the game. Therefore, we present a sorted list of possible matches for a link to a human expert and give reasons for the sorting. The decision about a possible link is up to the expert on this basis. He has to know which kind of semantic similarity is more important than others. And we can switch the perspective. Of course, the existing records can also simply be used for the search. Instead of adding boarding pass to the dataset, we just want to look up within the register, within the database, do we know the person who has the boarding pass? So a search with the known information from the example will then lead to the result in the table below. But which point values are assigned for which degree of match and what influence the individual values have on the overall score can be finely controlled by the user. That's important. He has to know what is important for him in his actual use case. So, for example, the user can decide for himself whether the common language area is relevant in this case or not. And this will influence the result and the derived decisions. I hope with this small deep dive into our platform and the mechanisms of semantic similarities, I could give you a small impression of how we support the creation and use of registers with our Intelligent Views platform. We use these and many other processes, for example, in the many German federal registers, which are very large and very frequently used. However, the procedure is, of course, independent of the specific application. The reliable consolidation of patient information in the healthcare sector is just as much an area of application as the maintenance of customer data in a continuous supply chain. So the question we specialize in is always who or what relates to whom or what in what way. As always, the time is limited, but I'll be available for follow-up. And if you have a problem that lies somewhere between the right dog food and a really great register, let's talk about how the Intelligent Views platform can help you. To inspire your ideas, I quickly touch on 3 application areas where customers and partners are implementing more solutions on our platform. Of course, it is no coincidence that we are actually doing similar things in all 3 areas. So in the healthcare sector, we use our technology to index the content of medical reports. This enables us to check the reports for completeness and for consistency. This also enables us to check and optimize billing to health insurers. So if we know what did the doctor, we can know who has to pay how some. Different industry, similar problem. Insurance companies have to evaluate a large number of risk and loss reports in order to assess risks or settle claims. So we support linking the written language with criteria catalogs to improve decision-making processes, to build up the structured information base from unstructured documents. And finally, investigative authorities are also faced with the problem of having to evaluate large volumes of texts. Here, the task is to record complex interrelationships, document them in a comprehensible manner, and check them for contradictions and gaps. Everything is completely different, but it's always about similarity. That is what our platform does. So we are confident that our technology can be used in many industries and applications. But why us? I would like to conclude by giving you 6 reasons to work with our platform and with us. First, we have great experience in using artificial intelligence in industry and public administration. Traceable and secure, no gimmicks. Second, we have our own knowledge graph technology, the only one that also includes complex rights management down to attribute level. Third, we are convinced that our success depends on the success of our customers, you. That is why we do not leave you alone with our technology, but help you to be successful. Fourth, the range of possible solutions is also reflected in our pricing model. Start small, keep small if you want, or let us grow together. Fifth, our software has been developed and tested for years in the German market. There's no data protection or data security requirement that we have not seen. And sixth, we don't have to do everything on our own, but are happy to have partners who use our technology in their solutions. So feel free to get in contact with me right now in our platform or whenever later through another way. But finally, I would also like to draw your attention to the two subsequent presentations in this track. In both presentations, you will once again be presented with impressive examples of the use of comprehensible semantic technologies in very concrete application examples. So for now, thank you, and I look forward to your comments and questions.